This is a math class, I know. However, I love music too, and music happens to have lots of ratios in it. So when I went, we heard 3 of the hi-hats, 1 of the snare drum. So every time I play a 4-beat tone, I've got 3 hi-hats to 1 snare drum. Ratios are defined as comparisons or relationships between 2 or more amounts. And when I say amounts, I'm talking about an amount of objects or things and how they relate to each other in those amounts. So in music, we saw it was a 4-beat tone that had 3 hi-hats for every 1 snare drum. And I can use it in cooking with 5 chocolate chips for every pancake. Maybe in sports on a co-ed softball team, there's 2 boys for every 1 girl. So let's say we took a poll of the favorite ice cream flavors in Mr. Inyart's class, and we noticed that vanilla had 3, chocolate 8, strawberry 2, and cookies and cream 5. If we wanted to buy only 2 of them, and we wanted to make sure we bought the right amounts, we would want to use a ratio, a relationship between those 2. Because I don't want to buy a whole bunch of vanilla or strawberry when I really needed to buy more chocolate and then have a bunch of people not have ice cream or not eat the ice cream and have a bunch of leftover. I want to buy the right amount, so I spend the right amount of money and everybody gets what they need. So I'm going to use my top 2, let's say chocolate and cookies and cream, and I'm going to write a ratio so that I buy the right amounts, and that for every 8 chocolates, okay, so chocolate is represented by the 8, that means I'm going to have 5 cookies and cream ice creams. And when I go to the store, I can notice that right here, this gives me a total of 8 plus 5. That's 13 kids, right? So if I buy 8 chocolate ice cream bars and I buy 5 cookies and cream ice cream bars, that's only 13 kids. But how I can use this in what we call equivalent fractions is, let's say I don't have 13 kids, in fact I have 26 kids. What I can do is I can use a table like this and lay out this information. So I know for every 8 chocolate bars, I'm going to buy 5 cookies and cream bars, and that's a total of 13 kids. But if I had 26 kids in class, as many of our schools do, how many chocolate bars would I buy, and how many cookies and cream bars would I buy? Well, remember, for every 8, we say this ratio, 8 to 5. I can also write it 8 with the word 2 and 5. And so that represents how I can say this right here. For every 8 chocolate bars, again, it's a relationship between these 2 amounts, I need 5 cookies and cream bars. So to get to 26, I notice that that's just double the amount, 13. And how do I get there, of course, is times 2. So that might come in handy later, which means I'm going to go ahead and start by trying to double both of those. Now, let's do another 8. If I had 8 more chocolate bars, that means I'd have a total of 16. Because 8 times 2 is 16. Which means I need another 5 cookies and cream, because for our ratio is 8 to 5. For every 8 chocolate bars, I need 5 cookies and cream. So I'm going to now put that 10. And so does 16 plus 10 equal 26 and give me my total? It does. So now I know when I go to the store, I need to buy 16 chocolate bars and 10 cookies and cream. So I can take that data and describe it in different ways. These are some different ratios and their descriptions. Notice that order matters. Whatever is in my description first, whatever I'm describing first must be represented by the first number. Whatever I describe second must be described by the second number. So if you remember the graph, you can rewind if you need to. Chocolate was 8, cookies and cream was 5. So my ratio of chocolate to cookies and cream was 8 to 5. My ratio of vanilla to chocolate was 3 to 8. And my ratio of strawberry to vanilla was 2 to 3. I want to be real careful with order, because in this example you can see I've got 2 happy faces and 1 sad face. And if I do something like this, or I write the ratio 1 to 2, then I'm confusing who's watching, because the order of the description are happy faces, then the sad face. And there are 2 of those and only 1 of those. So my ratio should be written with this picture as 2 to 1, because it is 2 happy faces for every 1 sad face, and therefore I could write the ratio 2 to 1. And so what I have here is a different number of red, different number of blue, different number of green, but a total number of objects. So there's a lot of relationships here, therefore there are ratios here, since ratios are relationships between 2 things. And so there's lots of different ratios I can write. So if I wanted to write this ratio, 3 to 4, what would that stand for? Pause the video now and see if you can answer it. 3 to 4 would represent the green to the red, because there's 3 green for every 4 red. We could try this all day. I could do this. What would that stand for? Pause the video, see if you can figure it out. That would represent the number of blue to the total number of pieces. Right? 12 is how many total I have, and 5 is the number of blue I have. And I could do this with all of my different relationships to show how the ratios would work. Bottom line, ratios are awesome, and you use them for all kinds of things. The better you understand these relationships and how to use math, examples, models, materials to help you figure it out, the better life's going to be. So live it, love it, enjoy it. It's math, baby.